All right, we are live. Hello, everybody. Welcome to live chat. I hope everyone is having a wonderful evening. Um, it's July 6th, and the number one question we've been getting is why has it been so dry? So we're going to talk about that tonight. While I'm also keeping an eye on the Mets game, which is driving me nuts because for some reason they forgot how to score all of a sudden. I don't know why, but it's actually a yearly thing where the Mets do really good for the first part of the season and then drive all their fans mentally insane by forgetting how to hit. So maybe they'll figure that out a lot sooner. Trade, please. Anyway, we have a lot to talk about tonight. There's a couple of topics I want to cover, including the seasonal setup that we're seeing with our precipitation, the evolution of the tropics, what's going on with that, some thunderstorms that we're keeping an eye on, the potential for showers and thunderstorms, and possibly some rainfall on Saturday morning. So there's a lot of factors here that we want to talk about. But before we go there, we need to understand where we've been. So what I've done, first let me pull this up here, is taking a look at our precipitation anomalies going back to April. I'm sorry. This is January 2022. And actually, you know what? There we go. Let's do April. Now, why do I want to do April? Okay. Now, the winter, you could kind of look at it, sure, and you could say for the year thus far, from January to July, this is where we've seen our precipitation set up. And sure, you can see some trends, but you don't want to use this anomaly because of the fact that we're dealing with a different weather pattern. So the causation of the anomalies isn't as well supported. But if you go to 90 days out, what is the same about this pattern? Well, we saw a resurgence of La Nina. We saw the Indian Ocean heat up, which enhanced La Nina. We saw the MJO basically bouncing around neutral. We've seen an enhancement of the polar jet stream, where we've seen a support for a trough being persistent in the northwestern Atlantic and a western Atlantic ridge trying to pop in. And we've seen that same evolution basically unfold and develop going from April to now. And as that evolution has taken place, we've seen more of a weakness along the East Coast. So that would translate to the development of backdoor cold fronts and slow-moving cold fronts from the west. So what is our anomaly from the spring set up? Well, it set up a very, very dry weather pattern over southern New England. I mean, that is excessively dry. Going into Long Island, it set up a dry gradient over southern New Jersey and started to set up a dry gradient over northeastern New Jersey, and especially the Hudson River Valley. Notice we have a very powerful moisture gradient, above normal gradient, over the Delaware River Valley. Now, you might be wondering, why does this matter? Well, the precipitation gradient that we see showing up here back from spring enhances the low-level moisture gradient, which enhances or weakens thunderstorm development. So that's 90 days out. Now let's look at 60 days out. Here is our new gradient. Again, you can see the line of above normal precipitation values. This is what's left of our influence of our backdoor cold fronts that have been constantly stalling over the spring. And then here's our cold fronts from the west stalling out and running into a wall of the maritime air. So you get your gradient here. And so what happens is that your thunderstorms march in, they intensify and slow down, and then fall apart because the low-level moisture gradient is so dry that it ends up killing the thunderstorms as they approach. So what we're starting to develop now is a feedback problem, a feedback loop, where every time we start getting precipitation coming in, it runs into this low-level dry air and kills off your showers and thunderstorms. Now we go to 30 days out. Our gradient is still lingering, very dry over northern New Jersey, over almost all of southern New England. Aside from this area right here, this was caused by a singular thunderstorm. And notice we have very much well above normal precipitation values over the southern mid-Atlantic. And look where we've seen thunderstorms focus. So if we're seeing thunderstorms focusing here, that means you have strong lifting here, which means you get strong subsidence here, which further enhances the feedback loop that we have in place. Now, 14 days out, it gets even worse. Our gradient is still in place over eastern Pennsylvania, but it's starting to fall apart. You're still seeing a focus over the southern mid-Atlantic, where we're getting our trough building in just enough where our stationary fronts are stalling out over the southern mid-Atlantic. So you're getting your thunderstorms feedback here, and you would further enhance the low-level dry air over the northern mid-Atlantic. To now, 7 days out, there's our continuation of our feedback process, now taking over much of eastern Pennsylvania, and you can see a drier weather pattern trying to take hold. So we have two main problems here in this precipitation scenario. One, in the summer, your precipitation is primarily driven by convective precipitation, thunderstorms. And thunderstorms are very sensitive to dry air. So when you get a lot of low-level dry air feeding back on itself, it tends to kill off thunderstorm potential. Now here's the caveat and wild card in this whole scenario. All it takes is one thunderstorm complex to break this feedback process to fundamentally change the entire precipitation evolution. One, it could be tonight, it could be next week, but it will happen. And when that happens, then the floodgates open up. Why? Because outside of the lower 10 meters of dry air that has been killing off of precipitation events, precipitable water values otherwise from 9 to 25 millibars to 700 millibars, even up to 500 millibars, have been ranging anywhere from 1.25 to 2.35. What does that basically mean? Well, it means that if we break this feedback process, the potential for intense heavy downpours is built into the pattern already. All you need is that trigger. So that's why we're seeing what we're seeing. What would fundamentally change this evolution would be a thunderstorm complex that can break this pattern, or an extratropical or tropical, remnant tropical low pressure system producing widespread rainfall throughout the region. You basically need a widespread rainfall event via, not convective, what's the word I want to use? More of a widespread rainfall event. The name of it just went right out of my head. Sorry. But basically, almost like a rainstorm that you would see in the fall. Okay? So that is why we're seeing what we're seeing. So as a result, this type of pattern is going to remain in place with this dry weather until we get that trigger to break it. Now, I would love to say I know exactly when this trigger is going to happen, but I don't. Because we're dealing, until we get to a point where we're not dealing with convective precipitation events like thunderstorm complexes and go more with a widespread rainfall event via isotropic lifting, until we get to that point, we're not going to see a change in where we're seeing the rainfall focus the most. So if I'm looking for heavy rainfall in this pattern, well, I'm going to look for southeastern Pennsylvania and southern New Jersey. Now, the problem as a forecaster is that you know that all you need is one precipitation event to break this pattern. So as a forecaster, it's dangerous to say, well, it's been dry, so it's going to continue to stay dry. Because all you need is that one rainfall event to lead to a flash flooding event that you're not forecasting. So that's why in the forecast for this past weekend, you had to go with the wording of unsettled. But notice I did say, hey, look, don't cancel your plans. Just be prepared for a passing shower or thunderstorm. And that's essentially what happened this past weekend. In fact, Sunday and Monday were absolutely beautiful. And I already see some questions on to why that was the case. So we'll talk about that in a moment. But the evolution of our weather pattern has been interesting in that this is a perfect example of how a microscale is, let's say, your street level, and mesoscale, which let's say is your county level or state level, evolution can overcome the synoptic large scale, like the Northeast or the United States size of a map, can override that weather pattern. So it can be a real pain in the neck. I know it can be frustrating, but believe me, if you understand what caused this pattern, then you can kind of pick out and see how it can change. So while we're studying that, let's take a look also at the tropics, if I can pick the right map. There we are. Not much going on in the tropics right now. I'm going to show you why. First of all, we know the Atlantic, well, it's remaining cool. Remember what I said, we're a negative AMO pattern. So that's going to influence the activity in the tropical Atlantic, more so the ability for rapid intensification. But notice in the last several disturbances, the model guidance has been far more aggressive in development than in reality. And that is a direct impact from the AMO. Okay, when you have a negative AMO, tropical low pressure systems have a harder time rapidly intensifying. When you have a positive AMO, like we've had for the past couple of years before this, tropical low pressure systems tend to rapidly intensify in that type of environment because you have much warmer water throughout the tropical Atlantic. So that's why it takes longer for some of these tropical low pressure systems to intensify. So we have that factor going for us. Then, let's see, I want to pull up this right here. This is the influence from the MJO. These are the phases of the MJO. Okay, this is our Nino area right here. And then this is the MJO phases right here. 1, 2, 3, 4, 5, 6, 7, 8, and then 1 again. In the forecast from the European guidance, notice we see a lot of suppression around the tropical Atlantic. On the GFS, we're seeing the same thing. And this is going through July. This is a sign that the MJO is not favorable for a lot of tropical Atlantic activity. I don't expect this to last. And again, I'll warn you guys, August and September will have the potential of being very, very impressive. But if we go by the MJO guidance, what we're seeing right now, this would suggest at least through July 1st, July 21st, that the tropical Atlantic would be more likely to be quiet than not. At least in terms of the atmospheric support and potential, it's going to be inhibited. What you want to see is the MJO to move into phases 7, 8, and 1 if you want to see tropical Atlantic activity. In that environment, what happens is that you start to get more support for strong tropical waves around Africa moving into the Atlantic, and that leads to an enhanced activity in the tropical Atlantic. Right now, we're not seeing that. Fingers crossed, because as much as I know I forecasted along with everyone else an above normal season, I frankly would not mind taking a bust on that forecast and having a very quiet tropical Atlantic season where no one's houses get flooded, no one gets impacted by major hurricanes or anything of that nature. But I have my doubts. So we'll see how that evolves. The La Nina will weaken as we head towards late fall. So that's going to be something to definitely keep an eye on as we move forward. Finally, let's talk about the activity over the next couple of days. Here's our stationary front hanging around. A few showers. Looks like it's going to be pretty active around portions of southern New Jersey for tonight, with this cold front pushing south. To be honest, I'm not seeing a lot of support for a very impressive activity on Friday. Definitely a few scattered showers and thunderstorms, but I'm not seeing the same support and same intensity that I was seeing beforehand in terms of the vertical wind shear or the cold air transport involved. So I like the idea of scattered showers and thunderstorms, but nothing all that severe. Wouldn't be surprised tomorrow if we get some heavier downpours along the coast, because we're going to have an easterly wind and you're going to have the maritime air undercutting the tropical air trying to invade from the southern mid-Atlantic. So don't be surprised to see some heavier rainfall, especially around the Jersey Shore. Again, this is the type of scenario right here that could start to break the dam in terms of your dry weather conditions. The problem here is that this type of rainfall, where you have an easterly wind, it's so hit and miss. What you really need is just a tropical low pressure system or a remnant tropical low pressure system to just bomb the entire area with heavy rainfall. But we'll see whether that starts to break the trend. And then here comes our next cold front coming in on Friday evening into Saturday. Again, a lot of this will be weakening as it moves on through. It looks like Saturday morning you're seeing this idea on the European guidance of an area low pressure around the Delmarva and some heavier rainfall around southern New Jersey on Saturday. I am very skeptical of that scenario playing out. The ensemble guidance does not support this, so I'm keeping it dry for now. But this is dependent on a short wave diving down and interacting with a stationary front. And we'll see whether or not that plays out. So the overall theme here is that the mesoscale environment that we have in place is inhibiting your rainfall chances. And until we get a rainfall event to override that, we're going to continue to see the scenario where rain comes in and basically falls apart. So what we really need to do is break that 10-meter dry layer, and that would start to change our weather pattern. We've seen this before, by the way. A couple of summers ago, this dry slot was not over northern New Jersey. It was over Monmouth County, to be exact. And every time we had thunderstorms approach, it would collapse. The thunderstorms would just keep on collapsing. We'd barely get any rain. Then we got one widespread rainfall event, and boom, it fundamentally changed the rest of the summer. So with that being said, I am going to start answering your questions. And let's see, we got plenty of questions in the live chat, premium live chat. And I see that YouTube is being its jovial self here. But yeah, I see a lot of good questions. Susan's going to help me out with some of this, and some of these people are messed up. Wow. You know, I never underestimate social media creating such interesting individuals. What can I say? All right, so let's start with the premium chat, and then we'll get back to everything else here. All right, so I have nocturnal. Our card says I have nocturnal clouds are generally seeded by meteors. Sometimes, absolutely, but is the greater cloud cover brighter coverage in part due to big volcanic eruption last year and launched material all the way to the mesofield. Um, there is some influence, but right now I don't have enough data to say to what degree. But there's definitely some influence. A lot of that, though, is going to be felt more in the lower stratosphere, and that really has not stood out too much. But again, it's definitely something that definitely we're going to have to keep an eye on and see what they're measuring out there from NASA. Have you had a chance to look at the seasonal Euro C5 July forecast, enhanced value expectations uh, for the Louisiana, Texas coast, Outer Banks, New Jersey coast, Long Island? I have taken a peek at them, and for those who haven't seen it, they are. Let me go back here. They are very, very active. Um, but there's a caveat here, okay? When using those models, you have to understand that they're forecasting warm core low pressure systems, and there is a lot of error involved in that. So what I do when I take a look at that is take a look at the 500 millibar pattern that it develops, and it's pretty much. Let me go back here. Looking like this. And I wanted to actually touch on this. This is a perfect. Notice in our 500 millibar pattern, we don't see a lot of change here. What do we continue to see? A ridge out west to the plains, driven by our negative PDO pattern here. So we got our heat ridge continuing. Our Western Atlantic ridge continues to be a theme, and a weakness in between. And guess what? That evolution shows up all the way through August. Same scenario. So what does this open up the potential for? Well, why are we seeing a higher threat for tropical low pressure systems in the Louisiana, Texas coast and the Outer Banks and New Jersey coast of Long Island? Well, if you get a tropical low pressure system getting to about the Yucatan Peninsula, this ridge axis here and the way that this trough axis is set up would drive any tropical low pressure system once it gets to this point here right towards the Louisiana and Texas coast. At the same time, anything that develops around the Bahamas or I don't know, along a stationary front like Colin did and tracking up along that stationary front as a, let's say, subtropical or pure tropical low pressure system, that all gets drawn up into this trough. And then you can get a negatively tilted trough out of this scenario, and boom, you can have a lot of trouble. Now, what this tells us, and what the European is trying to tell us, is that the pattern is favorable for a lot of tropical activity focus to be in those two areas. Why? Because the 500 millibar pattern would direct tropical low pressure systems in this corridor here and this corridor here. Because of the location of this ridge here, and this trough here. So it's a combination of those factors. Whether that means we're dealing with a lot of remnant low pressure systems, strong low pressure systems, or stuff that like what we saw the past day, where you had a tropical storm basically develop for 48 hours, if that, and then completely collapse, and you just get a heavy rainfall event. I don't know that. We don't know those details. But we know the favorable 500 millibar pattern that's going to be in place. Did the cold front this weekend push further south and east than had been anticipated, or was the low humidity Sunday and Monday purely a function of the low-level dry air feedback loop. No, that was driven by the synoptic pattern. What happened is that the upper level low that was swinging through from Ontario to Quebec dipped a little bit further south. It dropped south of the Hudson Bay towards south, I guess you could say northeastern Ontario, and then swung towards the St. Lawrence River Valley more so than to the north of the St. Lawrence River Valley. And that slight shift by about 25 miles pushed the cold front further south, which led to a much nicer weather pattern and much lower humidity for Sunday and Monday. Has the eastern tropical Atlantic gotten cooler relative? It seems the cold anomalies are a bit more pronounced than previously. Let's go back to that data. And what we've seen is definitely a bit of a cooling trend. Now, this is going to vary back and forth for the entire season. Do not be surprised you see this whole area warm up to neutral at times. Okay? But yeah, it has gotten a little bit stronger. But this is textbook negative AMO. Textbook. Colin forming was definitely a surprise. Excuse me. Yeah, I would agree. Even the NHC said it was a complete surprise. People were not prepared for it. Even the meteorologists in North Carolina were kind of surprised by it. But basically what happened is that everyone knew that there was going to be plenty of tropical moisture and rainfall and the potential for a wave of low pressure. But when the wave of low pressure developed, it had a lot of warm core characteristics. And then it continued to enhance those warm core characteristics, which surprised a lot of people and caught a lot of people by surprise. I think I said that 3 times. So yeah, it caught people by surprise. We have had summers with thunderstorms killing feedback loops before. I remember one not all that long ago, perhaps during the last La Nina cycle before the current three-peat. The feedback process can happen in El Ninos or La Ninas. It's actually more prevalent in El Ninos because the polar jet stream is much weaker, and so the cold fronts are much weaker. And so as a result, the cold fronts typically collapse before they get here in El Nino patterns. In La Nina patterns, the polar jet stream is stronger, so you have a better shot of getting those cold fronts to move through. But the way that this pattern has evolved, leading to a feedback from the previous influence of backdoor cold fronts, really has set us up to where we've been drier than certainly than what I've expected. I don't think this is going to last. And when like I said, when it snaps, I think it's going to snap pretty significantly. Did Colin form over the Gulf Stream? If so, I wonder if that is why it took on warm core. Actually, it formed right over eastern North Carolina. It didn't really hit the Gulf Stream until it got to the east of the North Carolina coast, and then to the south and east of the Delmarva Peninsula, where it briefly intensified and then it collapsed. So let's take a look at YouTube and see what we got here. We'll take the best question. Let's see here. Yeah. Yeah, it looks like my wife went nuclear on a couple of people here. Let's see here, which I could see why. I'm starting to get nice discussion, Steve. I'm starting to get concerned about the lack of rainfall in the Trenton area. Understandable. All the storms seem to be falling apart, as you said in your discussion. When can we expect a pattern change? I would look for a strong low pressure system. Doesn't necessarily have to be tropical to produce a widespread rainfall event. That will break it. Now, a little warning here. If you do get a heavy rainfall event in this scenario, one, be aware of your gutters. If there's anything that is left as far as any trash or anything to block it, it will cause flooding. If you are a farmer, be prepared for your topsoil. You could get a pretty drastic runoff, and lose some of your topsoil as a result. A lot of people don't prepare for that. So if you know a rainfall event is coming, it's good to moisten up your topsoil a little bit to get it prepped for that heavy rainfall event. Otherwise, it'll hit the topsoil and then just wash it away, and your hard ground uh, doesn't absorb the heavy rainfall event that comes in, which you need. The best type of rainfall in this scenario is actually a series of light rainfall events that slowly moisturizes the ground and then allows for the topsoil and for your hard rock below that to take in the water and not allow for a massive runoff. Let's see here. I live in Dover, Delaware. Storms come across the Chesapeake Bay, get diverted either north or south of Dover. What causes the diversion? Is it something in the current weather pattern or something else? I know exactly what you're talking about. Let me pull up. So, let's zoom in. And let me put in overlay city labels here. Okay, so here's Dover, right? Now, you have your thunderstorms come in. You see the way the coast is kind of concave and then it kind of dips in here and you get all these islands here. Well, what happens is that you get a lot of these low-level winds. And if your upper-level winds are relatively weak, what happens is that you get all these areas of convergence and confluence at the lower levels, which tends to split these thunderstorms. So what you're essentially seeing here is the influence of the winds around this body of water, and that the way that the coastline is shaped, combined with sometimes you get an inflow from your bay, from Cape May Bay right here coming in. So you get this interaction here, you get this interaction here, and this causes your storms to split as a result. So you're seeing somewhat part of that right now. Here they come through Baltimore, and watch as they come through. This is going to weaken and split and get forced south because you're getting convergent winds here and divergent winds here. So as a result, you get your thunderstorm complex driving in here without any inhibition, thunderstorm complex here that gets shifted south, and so you are constantly in this area of dead zone. It doesn't always work out, but that's essentially what's happening here. This is a great example of microscale and mesoscale wind convergence and confluence literally at the street level, influencing the way that thunderstorms develop. It's all because of the shape and the orientation of your coastline to the west of you and to the east of you. Let's see here, and wow, we have a lot of questions. This is great. Is there any? Of course, we have the typical. Is there? Oh, Mets might actually score. All right, good job, guys. Is there any widespread severe weather event? Nothing on the horizon right now. Of course, I'm always keeping an eye on it, and you can always check out the premium consulting membership because every morning I update the chart to see if there's any severe weather on the way, 90 hours out. And honestly, you don't want to go beyond 90 hours out for severe weather, especially convective severe weather, because beyond that point, there are way too many questions and uncertainties to really say anything for certain. And just so we were clear, the pattern we're seeing right now is pretty much what we've been seeing. I don't see any signs for any sustained heat waves anywhere. Yes, even the Philadelphia metro. Let me put a little caveat on that. If you're going to see a heat wave, which is 90 degrees or higher for 3 days straight, it's going to be in southeastern Pennsylvania and southwestern New Jersey, right around the Philadelphia metro. The problem is that I don't see the pattern really developing in such a way to support that. But if it is going to happen barely, and we're talking about 90, 91, 90, that type of scenario, it's going to be in those areas. Steve, your videos are awesome. Have said that. Please turn off comments. Don't do live chats. Just read the comments to understand why. I look. I get it. Um, I can't control social media. I can only control what I respond to and what my wife responds to. And there are far too many great questions that I already got just from this chat and from the premium chat to not do that. I can't help it that other people are too immature to enjoy what we're doing. But I think that it's important, and we can't stop doing something just because other people are immature. Because if I started doing that, I probably would never have been a meteorologist, right? So if other people are going to be immature, that's their problem. Oh yeah, and we do block them. It's just that bots, you know. What effect do low cap mount? Ooh, this is a good one. All right, this is from Opie. Let's see. What effect do low cap mountains such as the Huachicas have on severe weather in the summer and winter weather during the winter? Oh man. Okay. All right. All right. All right. Orientation matters. The Okay, how do I explain? Okay, all right. The way that weather systems interact with mountain ranges or enhanced hilltops is strongly dependent on three scenarios, three setups. One, what are your low level wind variables? Two, are there any large scale, synoptic scale forcing mechanisms that can override those factors? And three, most important, and three, is there any competing microscale or mesoscale factors that can play on those mountain ranges? So in the winter, when you get an easterly wind, if the easterly wind is perfectly oriented to the east northeast, then that can enhance snowfall rates in northwestern New Jersey and the Poconos because you're taking in moisture and you're upsloping up against the hills and mountains. In the summer, the way that a thunderstorm moves through the region, if it drops due south, typically you don't see a lot of impact on thunderstorms here and here, but due south thunderstorms enhance thunderstorms here and weaken thunderstorms here. Why? Because as the thunderstorms come off of the Hudson High Plains, they subside, sink in, and the base starts to sink, and then you get subsidence, and that weakens the thunderstorm evolution. But that same evolution leads to convergence and confluence at the lower levels, pulls in moisture from the Long Island Sound, and can enhance thunderstorms and rainfall rates around Yonkers and New York City. At the same time, if you have a cold front that's coming in from the west while you have thunderstorms lifting from the north, let's say from a warm front, that can enhance thunderstorms around Franklin and Habitage, even Point Jervis, but weaken the thunderstorms over New York City because it has more influence of more of a stable air mass coming off the Atlantic Ocean because it enhances the low-level winds. I could keep going on for this for hours. I guess what I'm trying to say is that there is no hard rule. Each scenario is dependent on a lot of smaller factors that become so numerous it leads to chaos. And the best way to handle that scenario is first watching the thunderstorm complex and seeing how it reacts and evolves as it is moving, and understand the environment that we're in. Now, all of that can be thrown out with the bathwater if you have a strongly uh, unstable atmosphere with plenty of low level moisture. So if you have precipitable water values around 2, you have a lifted index around -5, you have strong vertical wind shear, you know what matters then? Which thunderstorm cell is the strongest. Because then in that factor, everything else is overridden except for the fact of which area has the strongest rising and sinking air. So that can influence your forecast. So there's a lot. There's a lot to consider. All right, now let's go back to the previous chat. Let's see here. Okay. A card makes a great point here. Those who are frustrated on chat on social media can sign up for premium member. That's true, because in the premium section, there is none of that nonsense. And of course, you get your questions answered first. All the questions are answered in the premium chat, whereas in the YouTube chat, I just pick the best ones. So if you get missed, sorry about that. Um, Avoids the social media nonsense. Plus, they get all the good stuff that comes from premium membership. That is true. Poconos are a great example, especially Mount Pocono area, where you have that big, shallow saucer dish on top of the mountain, which gives valley type effect at higher elevations. Exactly. You know where else you can see that? In central Jersey, right around Monmouth County. Let me see if they show it very well here. Okay. Right in this area right here. This is my area where the forecast becomes very difficult in the winter and in the summer. I'll explain why. You get this little valley that shows up right around Freehold in central Monmouth County. And it's unique to central New Jersey. And what happens in this valley is that you tend to get cold air trapped here. So in winter storms, you tend to get your snow and sleet to last a little bit longer and freezing rain, especially right around Freehold to roughly Allentown. So right around here, you get an enhanced high icing potential. In the summer, what can happen is that you get rain-cooled air locked in here. And then if you have a trailing thunderstorm event here, what that can lead to is a very heavy rainfall event in this area, because what happens is that your thunderstorms get elevated and lifted, and you can end up with a training effect right in this area here. At the same time, sometimes in this environment, you can get a scenario where if thunderstorms are dropping due south, they can come into this bowl shape area, and because of the way that the land sinks in here, the thunderstorms can weaken as they drop through central New Jersey. So a lot of cool stuff here. There's a lot of things you can learn in terms of the influence of the geography of the Mid-Atlantic and how it impacts the weather pattern. It's one of the most difficult regions to forecast for because of that, because there's so many geological dips and shifts and influences from the coastline to the way that the land is set up, from the coastal plain to the Appalachians, that can all have an impact on landmass, on your weather forecast. We have the same thing in Hillsborough, low areas between the Southlands and the ridge along 22, and we get cold air on clear, calm nights. Yep, for some reason we don't do so well with thunderstorm training. In fact, some stuff seems to move around us, not sure why. Okay, Hillsborough. Let's see, that is further north. Let's see if I can find it this relatively quickly. Here, let's see here. I know it's somewhere around here. Okay, So basically what you have here, you have the Hudson Highlands here, right? And when you have thunderstorms, and you mentioned thunderstorms rain, in fact, when thunderstorms move around us, not sure why. Okay, that's because of the way that the orientation of these mountains set up. I'm willing to bet you're somewhere right around here. Yeah, it definitely does have an impact. Even especially when you're dealing with warm core, i.e., um, convective storm systems. What happens is that because of these different ridges here, these thunderstorms, you get a lot of thunderstorms tending to split right in this area right here. Because what happens is that these thunderstorms come off of these highlands here, and they also move into these valleys. And the way that the winds converge and diverge in these areas leads to these thunderstorms basically splitting around the high points of these ridges. So, depending on how the thunderstorm comes south and interacts with these ridge points, that's how they can split. So, all right, so you're right here. Okay, this is perfect then. Wait a minute. Let's zoom in. Let's zoom in right here. Okay. So, you have a valley here. You have a valley here with a nice lake. Then you have some ridge points here and up here. So as your thunderstorms drop south, you have convergent winds here. You have divergent winds here. Convergent winds here. So your thunderstorms as they dive south will split over here. So they'll drop here and miss you. And that's typically what happens. My section card also adds in there. My section in Union County has the same issue as thunderstorms tend to weaken if they are coming from the direction of Wichita Mountains, Wichita, out of northern Somerset, southern Morris, and tend to die out. Yep, that's why, guys, because the way that it's splitting around that ridge axis. Let's see here. Oh, did the Mets? No, that's an out. Well, only down by one run. Let's see here. It's 8:47, so I'll take in the last couple of questions. I hope I answered your questions on the rainfall scenarios here. The hope is that we should see some rainfall events overcome some of this, and the forecast here remains pretty active for that potential. Now, we're seeing a lot more influence from polar air masses than I thought we would this summer. But still, it's been relatively active for the summer. It's just that the way that precipitation events are set up just isn't playing out the way it should. Still, the evolution is such that the pattern remains pretty interesting still. Okay. One thing about the chat, guys, is that, and this is for YouTube followers, I tend not to do specific forecasts for specific days. It just leads to way too much of that being asked in the chat. Let's see here. Can we get a full chat tonight on archives? Yes, Dave. All right. So this is good for premium members. All right, just so you know that when this live chat is done, you can go back and watch the whole thing all over again. Okay. What happens is that after it's done, I'd say about 2 minutes after, you can go back, refresh the page, click it, and then you can watch it again. What did things look like for Sunday and Monday of next week? You mean this Sunday, right? Actually, it looks pretty good. Sunday, especially Sunday. Sunday looks absolutely beautiful. Monday looks pretty good too. I'm a little wary about a trough that might be hanging around the coast. But overall, I think that Sunday and Monday look to be really good. I really do think that the pattern looks pretty nice. In fact, let's pull up the temperatures. And yeah, generally in the lower to mid 80s for this time of year, not bad at all. So, card, it looks like pretty good. So let's see here. I think that let's see. I think I answered all the questions for tonight. It's 8:50. I think we covered pretty much everything. Uh, so just to recap, the weather pattern that we're in right now, rinse repeat, looks like it's going to continue to remain in place. The rainfall event, the lack of rainfall, should I say, is driven by the influence that we had in the spring with our backdoor cold fronts interacting with our cold fronts coming in from the west, leading to a suppression of rainfall over northern New Jersey and southeastern New England, which has led to a feedback effect, which is killing off our thunderstorms. The changing factor of that will have to be a large-scale rainfall event, possibly a remnant tropical low-pressure system to overcome this mesoscale event. Any thunderstorm complex will be able to break this event, though, so we have to keep an eye on it for that. Nothing really doing in the tropics right now. It looks like it's going to remain quiet through the middle of July. Don't be surprised, though, if we get something kicking up, especially right along the coast. And overall, the influence of mesoscale and microscale influences from geography to coastline has a major impact on whether or not thunderstorms impact your region and how they do. And each thunderstorm scenario has to be watched because there is no hard rule in these situations. So I think we have it all covered for tonight. Thank you for, again, joining for tonight. I really appreciate it. And as always, stay safe out there.